Hi, hello, welcome to Unnati Education videos. So in the last video, we were discussing about instantaneous velocity, how to get instantaneous velocity from position time graph that we have seen. And two more points, those you have to remember in this particular part is magnitude of instantaneous velocity gives the instantaneous speed. Okay, if you take the magnitude of instantaneous velocity, that gives instantaneous speed. Instantaneous velocity is a vector quantity, and if you just take the the magnitude only without considering the direction, if you take the magnitude only, that gives instantaneous speed. And for an object in uniform motion, instantaneous velocity at any point or at any instant is same, which is equal to average of it, means average velocity of it. So average velocity will be equal to instantaneous velocity in the case of uniform motion. Okay, remember these 2 points. These may be asked for competitive examinations also. Sometimes the second one is very important. Few times I have seen that in CET question paper. So just remember that. Next, we have to see what is acceleration. What is acceleration or average acceleration? See, definition wise, it is the rate of change of velocity with time. Rate of change of displacement with time is what you call as velocity. And suppose if you calculate rate of change of velocity with time, that is called acceleration. That is the change of velocity. Rate of change of velocity with time, that is acceleration. Okay. Its unit is meter per second. Velocity having unit meter per second. Again, per time you are calculating velocity per time. So it is unit will be meter per second square. Okay. Acceleration is a vector quantity. It is also a vector quantity. Okay. As velocity has got direction, acceleration also has got direction. That is why it is a vector quantity. And average acceleration, again we can define it as change in velocity divided by time interval in which the change takes place is called average acceleration. So average acceleration can be given mathematically equation wise as v2 minus v1. Let us consider v2 is the final velocity, v1 is the initial velocity, and divided by t2 minus t1. t2 is final time and t1 is initial time. So it is nothing but the change in velocity by change in time. Okay, delta v by delta t. This is the equation for average acceleration. Average acceleration is given by v2 minus v1 by t2 minus t1, or it is equal to delta v by delta t, where delta v is change in velocity, delta t is change in time. Okay, it is given where v1 and v2 are initial and final velocities, and t1 and t2 are time t1 and t2 respectively. Okay. And if an object increases its velocity with the time, then that is uniform positive acceleration. Suppose if an object increases its velocity with time uniformly, that is what you call as uniform positive acceleration. And suppose if velocity decreases with time, it says the negative uniform acceleration. That means it is negative. Velocity decreases with time means it is negative acceleration. uniform negative acceleration, or we have other names also for that, deceleration or retardation. Deceleration and retardation. So what you have to remember is, whenever velocity increases with time uniformly, that is called uniform positive acceleration. Suppose the velocity decreases uniformly with time, that is what you call as uniform negative acceleration, or some more names for that. The two names are deceleration or retardation. You have the names here, deceleration or retardation or negative acceleration. Okay, you have to remember this much. Next, velocity time graph. We have seen so far about position time graph. Next topic is velocity time graph or VT graph. In detail, we will discuss about velocity time graph or VT graph in the next video. So till then, you read this much about acceleration and remember all those points I have told. All are important. Do remember all the points. Okay then, thank you.